Next on the bench is a Marantz 2220B. According to Hi-Fi Engine, these were manufactured from 1972 to 1974, 20 watts per channel. I don't know anything about this. I don't know if it's working or not. So what we'll do is we will do an inspection of the inside before we turn it on. Assuming we don't see anything that needs any immediate attention, then we'll connect it to some music source, power it on, kind of see what it sounds like, and go from there. See what we have to do. First thing I'm going to do is I'm going to remove the cover, and then we'll get into the inside and just kind of poke around and see if there's anything that we have to address. So before we get into, sorry, my mic is checked. Before we get into testing this to see exactly, what's working, what's not working, the functionality of the unit, we need to power this on using a dim bulb tester, and then I want to check for DC offset at the outputs. So what the dim bulb tester does for us is it will help protect if there's a short, right? If there's a shorted component like in the amplifier section. So what the dim bulb tester should do is I should, after I hit the power button, this will flash. It will dim down to where it's either hardly visible or there's nothing at all. Typically you're going for a bulb that's 150% or maybe 200% of the wattage of the unit. So this is 20 watts per channel. I'd want at least a 40 watt bulb. I have a 75 that was handy, so this will work for at least this initial test. So here's kind of the sequence of events, I guess. So I'm going to hit the power button. This is going to flash. It should go dim. We should hear a click from the relay, and then I'm going to test at the outputs to make sure there's no DC voltage present before we connect any speakers or do anything like that. So let's turn my multimeter on to volts DC and hit the power button. Actually, I'm going to hit the main speaker button and the remote speaker button, and we'll turn it on and see what happens with the dim bulb. So flashed, went out. There's a very, very, very dim glow. The relay just clicked. So far everything is good. So let's measure for DC at the outputs. So it looks like left channel A I've got almost 0. Oh, right channel A I've got 1.7. So that is not good. B, almost 0, and then B on the right. If I can do this up. $1.7. So we have an issue. We have an issue with the right channel on this receiver that we're going to have to figure out before we get too far into doing anything else with it. So I'm going to power this off. I'm going to pull the schematic, and we're going to start testing voltages. So I have printed up part of the service manual, the alignment procedures to align the amp section for when we get to that point. So these will just be set to the side for now. I'm wondering, sometimes these, ooh, that's kind of loose. Sometimes these variable resistors go bad. So before I test for voltage, I just may do an in-circuit test just to see if there's any anomalous, readings between, what is this? This is 33 and 34. Because I mean, you know, these variable resistors going bad could cause that issue. So let me grab. You know, it's funny. I have different multimeters that I like to use for different things. So the Fluke is nice. I like it. This is probably my go-to right here. It's ideal. I'm going to set it to resistance, and I'm going to take some readings. And I don't know what these are set to. I can look at the schematic and figure out what the resistance should be. But I just want to do kind of a basic comparison between right and left on this, just to kind of see. So this would be, well, let's see. So I'm getting 141 ohms on 734, and I'm getting 127 ohms. Here I'm getting 4 kilo ohms, and here I'm getting 4K as well. So let me just check this one again. Oh, interesting. So, oh, no, same over here. Okay. Yeah, the best way to test these would be to pull them out of circuit. I just wanted to see kind of if something jumped out without getting too far into testing everything. Now what I like to do is start with the power supply and check for the pin voltages, and what works best for me typically is to print it up like this and then use highlighters as I'm going through. Right, green is good, red is bad. So this will give us some different voltages to measure on some of these pins. So the ones that I'm most interested in are the ones that are going to the power supply, or the amp section. But I'm just going to hit all of these starting at J. Those are AC voltages over there. So I'm really concerned with like 804 through 813, and not all of those are going to be voltages we have to measure. So let me grab my little grounding clip. And get this set up. And ground that. And all right, let's start checking for some voltages. All right, so we're going to start checking for voltages. I'm going to pull this off of the dim bulb tester. If I left it on, the voltages would be slightly less than what they should be reading here, but I just want to see how close these are off of mains power, so turn this on. So the voltages here looked okay. So I'm going to set this to the side in case we need to refer to this again. And now we're going to start looking at voltages in the amp section. And I'm going to start with the voltages at the outputs. So we're going to be measuring emitter, collector, and base voltages starting at the outputs. And I should, and we're going to start by testing kind of what we can without getting the clips out and turning the power off and on. So let's see what we find. Well, I can't get in there with my lead, so I'm going to have to use my mini grabbers. These are the long mini grabbers. Even though these are helpful, useful, that thing opens up pretty wide. So you've got to be careful. You've got to be, you can't just jam that in there and hope for the best. So I'm going to power this off to be safe, and I'm going to start checking base and emitter voltages on the outputs. So we had some kind of crazy voltages on these two outputs. Since it's both outputs, I'm guessing the outputs are okay. It's probably an issue with maybe one of the drivers, one of the driver transistors, and we're looking at the odd side of the board. So those can I can pop those out pretty easily, and I'm going to throw them on my tester just to make sure that they test okay. I mean, they're not shorted. I would like to know for certain if they're good, but it would be very odd to have both of these be bad. So maybe before I do that, I'm going to work my way back. I'm going to start on the other side of the board, looking at, oops. Well, I got to figure out which one is HO1, HO2. I'm assuming HO1, HO2, HO3, HO4. But yeah, that would make sense. No, yeah, 1, 2, 3, and 4. So 3 and 4 would be right channel, so that's even side. Man, when these are like twisted up, it can get a little confusing. So what I want to do is check for voltages on these drivers. Complementary pair. Let's see how easy those are to get to. Oh, those are interesting. Weird. But here's what doesn't make sense. So these transistors, yeah, that'd be our left and right. But left is so left is good, right is bad. So even, yeah, that's what I just said. Man, I'm glad it's 100 degrees in this garage. Makes it so much easier to know what the heck I'm doing. So let's think about this. Let's think about this. I want to get let's see. if I can get, oh man, I can't. And that should get me what I'm looking for. Man, that's 1.8 on. So what I'm looking for is 0.3, 0.5. That one I can actually get this one from down here without clipping it on. Yeah, and these are all high. These are all high compared to this side. See, there's 0.5. And then this one is probably, I don't think I'm really hitting what I need to hit there. 30, okay. All right, let's start looking at voltages on that even side of the board. See what's going on. So I'm kind of used to things kind of staying consistent on these. So here we've got like a combination of, so we have even numbers and odd numbers and even numbers and odd numbers. I'm kind of used to channels being kind of consistent that way, so I need to figure out which is which here. So I gotta mark these transistors, figure out, because these are the two that I'm seeing bad stuff on. Seeing the voltages are not what they're supposed to be. So like, is this 3 or 4? Like, what's the deal? Is it 2? Looks to me that 1 and 4 so we have 2 SA627s. So I don't know if 1 is top and 4 is bottom. But there's a 627. And those are 2 SD188s. But so the way it's set up on the side is there are two 2SA627s on the top, two 2SD188s on the bottom. So I don't know if that's an error there, and if this is like 1 and 4 and 2 and 3. Have no idea. No earthly idea. And everything is packed in there pretty good on this, and this is like a simpler kind of amp to. It's a smaller, simpler amp to work on, but man, it's weird. So 711 and 712. 711 and 712 are the adjusters for the DC offset. One thing I'd like to see is if moving 711 and 712 actually does anything to the DC offset. So there I've got it. Right speaker, probably not. I mean, those are really high. So turn that on. I just want to see what happens. Now, didn't I just have like a volt on there? And now I have what is going on with this? It's 0 and that's 0 now. Weird. So one thing I did notice was this pot was turned all the way to the left, but that's 734. That's for the bias adjustment. So that is strange. That's strange. I'm gonna see and get my other tester here. See what happens if I move that potentiometer. Maybe that potentiometer, or that variable resistor I should say, is kind of wanky. So let's turn this to, so that's on DC. Oops. And I had it on DC, and I'm going to adjust these are plastic. I can actually use a screwdriver. I could use my hand. Weird, nothing. What? That is really, 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 really strange. That's really strange. How I went from having, you know, 1.5 volts to having nothing now. Well, let's see if this will, let's see what happens with this. Let's see. I'm going to pop this bottom off and we'll see if we can actually set it per the specs. So the Marantz is turned on its side to make the alignment easier. Still really curious as to what is going on with this. But what we're going to be doing is we're going to be connecting a voltmeter between positive J12, negative J18, and we're going to set the bias first to 20 millivolts before we set the DC offset, which is kind of strange to me. Normally it's DC offset then bias. So we're going to do positive J12, negative J18. I don't know, probably no good way to do this. What I may do is connect this and then move the camera back on top. So 12 and 18, 12 and 18, 13 and 19 over here. So positive to 12. And negative to 18. So I'm back up top now with the camera, and we're following the amp alignment section here. Positive J12, negative J18, setting that to DC, and I'm going to move R733 until it reaches 20 millivolts. And 733 is, can't really see it, it's this potentiometer, or that variable resistor right there. It's on. Now I'm getting 1.1 volts. Look at that. Oh, well, I don't have a dummy load, but that should not affect it. So now I'm getting a volt again. Now I'm getting a volt again. So I'm going to stop what I'm doing in terms of the DC offset and the bias settings, because I'm not going to subject you to my poking and prodding around for 10 minutes. What I did was I set this to the side and then did a little bit of checking on Audio Karma, because Marantz service manuals, Marantz printed circuit boards, they're kind of, I'm not going to say notorious, but it's not uncommon for them to have errors. And that's what is going on here. So this power amp adjustment, I'm not going to say it's an error, but this is not a good way of checking for bias or adjusting bias, right? So actually we want to go from, on one channel we go from 714 to 716, and then from the other channel is going to be 715 to 717. We're still going to adjust the resistors that are noted here, 711 and 733, right? But we're not going to use these test points. We're not going to use 712 and 718 as test points. Now I have not tested this. I'm going to see if this actually gets us where we need to be. But yeah, so it's one thing to be aware of when you're working on these. You know, if it doesn't go as planned, I started to kind of chase this problem when maybe it isn't a problem after all. So that's why I'm going to edit that part of the video out. I usually just speed through stuff that I do. But I'm going to edit that out because you don't need to see me poking around and really getting frustrated, right? So I have removed the screws from the bottom. And I will keep this handy just so I know I'm adjusting for 20 millivolts, and we're going positive is, I'm going to assume that positive is, and I'm going to do this with the unit upside down, and then to adjust it I'm going to have to flip it up on its side, but I'm going to go positive to 714 and negative to 716. So 714 is, at least on this unit, is this post with the orange wire going to it right here. I may have to use, I don't like to use clips, I like to use these mini grabbers, but that's probably going to pop off of there. Maybe it'll stay. So that is 714, and then 716. I'm going 1, 2, 3, 4 posts away. So let's see if that gets us where we need to be. We're setting the DC offset. Get this connected to power. Make sure it's off. Okay, so that's off. Everything's flat. I do need to have a dummy load connected, so I have a dummy load here that I use for my oscilloscope. Connect this real quick and connect this side. Not that it really matters. Alright, so I have an 8 ohm dummy load, and I could just keep the speakers. If I had 8 ohm speakers, I could just keep them connected. Turn this to DC voltage. And ideally, we should let this run for 10 minutes. So what I'm going to do is I'm going to see if these pots will even adjust, right? If what I found on Audio Karma is correct and we can get 20 millivolts, right? So I'll do this channel, then the other channel, assuming everything goes okay, and then we'll check for DC offset, make sure that it reads 0, and we can do that right at the speaker terminals. And then what I'll do is I'll let this run for 10 minutes. I'm going to come back and readjust it. If anything crazy happens, I'll shoot some video, but if not, then we're going to say that this is okay. So, power on. So we're getting 16.2. We should be getting, and I don't even really need to use a screwdriver here. So I'm going to first adjust. I'm going to assume that it's 733. So let's see if 733 adjusts that. And let's see if we can get our 20 millivolts. See if it moves it. Yep, oh, that moves it. And we were close. I wanted to see if that could adjust. So 19.3. You know, it actually will probably be easier to use a little screwdriver or some type of adjustment tool. Got my phone going off, got my dog barking at me. Oh, goodness gracious. So I have 2 cattle dogs and I don't have any cattle. So that's what I get for having 2 cattle dogs and no cattle. If I'm in the garage, they need to be in the garage with me. And they're going to bark because they hear my voice. So 19.7. 20. So this channel looks good. I'm going to go ahead and connect this to the other channel. So I'm going to break here, go see what my dog needs, and come back and do the other channel. All right, so here are the dogs. Hey, Ralph, come here. Ralphie, come here. Get in the picture. Here, come over here. Sit. Both of you guys sit. So it's Ralph and Stella, but as I like to refer to them, sit. I said sit. We have never and again. Never again will I have cattle dogs without having cattle or a job for them. So if you hear barking in the video, it's one of these 2 dogs. When the FedEx man comes, you know that's a major threat. When they get bored or they hear me talking in the garage, they think I'm talking to someone, so they need to get involved. So Ralph and Stella, say bye. You guys are going to go back inside and take a nap. Sit. Hey, sit. Both of you sit. Say bye. So it took me a little while, but I think I have a kind of a plan of attack on this. So again, I'm not real efficient at reading my schematics in terms of exactly what everything is doing, but when I went through and I kind of traced where all of the like out of whack readings were, right, where they were high. That's in pink, and then green is where it was good, right? Anything that tested good. So it kind of points to, and these green highlights are just for resistors. It kind of points to kind of 710 and 712, right? As good candidates for causing this issue. I did test these 3 diodes, H718, 720. And 716, wherever that is. I did it a while ago. So anyway, we've got 3 diodes kind of right next to each other, and all 3 of them were out of whack in terms of voltage readings, but the diodes themselves in circuit anyway, they tested good. So I'm really suspecting H710 and 712. So H710 is a 2SC945. I'm going to replace with a KSC 2383. I can replace it with a KSC 945 as well, and I do have some of those. I'm going to try the 2383, and then for 712, a 2SA 733, I'm going to try a KSA 992 and see what happens. If that resolves on this channel, then I will replace those same transistors on the other channel just so it's even on both sides. So that's kind of where I'm at now. If that does not solve it, I'm going to look at 702 and 704 and maybe replace those, or 708. But I think it's got to be in some of those transistors on the board. So that's what I'm going to do now. So I've replaced those two transistors, 710 and 712. So let's see what happens. Oh, plug it in first. Power. Listen for the relay click. Negative 1.8. So nope, that didn't do anything. So 710, 712 are not the issue. So now let me move on to 701, 702 and see if changing those fixes the issue. So just an interesting note, the schematic, or the service manual says these should be 2SA 763s in H702 and H704, but they're actually 2SA 722s. Same sub I'm going to use, but just a note that they were different than what the service manual indicated. So I just replaced 702 and 704, and we'll see what that does. I really hate shotgunning parts, but at this point I just it's just not jumping out to me like what the issue might be. So normally I don't like to do this. I like to have it kind of self-ID, but it's not doing it. So there's the relay click. And I'm getting 53 millivolts now. So it appears that it was 704, 702 that were causing the issue. So let's throw those on my meter and kind of see what was going on with those. Whoops, wrong one. So let's see. So they were KSA 992s were the replacements. So let's see. This is a new 992. PNP transistor. Okay, gain on this is 525. Okay, so gain on this is 525. So what do you suppose these are going to measure? $479. Resistor shunt between B and E. HFE5. So there is the problem child right there. So I was close, right? The prime suspects to me were 710, 712, and then I thought that these were potentials as well. So, yep, so it was 704, 702, one of those two were bad. So, those have been replaced. Now I'm going to go ahead and do the other side just to make sure that we're even on both sides of the board, and we'll set DC offset and bias and call this one good. So it looks like the new transistors went in and took care of that problem of DC on the right channel. Looks like I have to order some new transistors. I didn't realize I was that late. So now we're going to go back to doing the bias and DC offset. And I'll let it run for about 10 minutes, come back and check it, and then we'll test it. So, but what I want to do first is put these last remaining screws in to the board. You know, before I go too crazy with that, I do want to make sure that I can set the bias and DC offset on this. So let's go back to what we started off doing. And maybe this is a little bit better. So I know you can't really see the pins, but here are the pins I'm going to be attaching the leads to. It's going to be a negative to, I got to look at what I wrote down here earlier. So it's going to be what, negative from, I think it's 14 to 16, and then 15 to 17 is what it was. And we're going to adjust that for 20. So I'll move this over to this side so you can kind of see what I'm doing. So negative on $14, positive on 16 if it decides to stay. DC voltage, everything's at minimum. I must have those swapped around. Oh yeah, I've got them swapped around. So this is going to say negative, but if I can get to negative 20, that's where I want to be on these two. So first going to turn 33. We get 20. Oops. Problem is none of my adjustment tools are big enough for this particular adjustment pot. So we have 20 millivolts there, and then we're going to do from 17, it's going to be negative lead, to 15, going to be positive lead. 18, 19, 19.9 there. So I'm comfortable with that for right now. And then we're going to go and do DC offset. Negative goes to 722. Then we're going to be looking for 0 volts on 23 and 24. We're going to adjust. So I've got negative 2. Go the other way. I'm going to have to use a screwdriver on this. I know we're using metal, but that's a plastic. That's the only way I can really get this to adjust. So I need to get that to 0. Don't know that I'm going to get it much better than that. There's 0. Now we're going to do 24. 24's got a wire in the way. Oh my gosh. So 24, I'm going to adjust this pot to 0. And I'm going to let this run for 10 minutes and see how that adjusts down, see if that's going to work for us. So if something pops up, I'll click back on the video. Otherwise, the next thing you'll see is me buttoning this thing up. So there you have it, repair of the Marantz 2220B with high DC offset on one of the channels and basic service, pots cleaning. Didn't change the bulbs. I'm going to go with kind of the natural look here on this one, so no LEDs, no LED upgrade. So as always, if you like what you see, hit like, hit subscribe, and I will see you next time.